Some planets follow the rules. They orbit their stars in neat, predictable circles, just like the planets in our own solar system. And then there are the others. The rule breakers. Today, we're talking about a type of planet that, according to everything we thought we knew, simply should not exist. Yet, they do. And astronomers keep finding more and more of them, scattered across the galaxy like cosmic glitches. These are the planets that defy our understanding of the universe, forcing us to question the very foundations of planetary science. For decades, the scientific consensus was clear. Giant gassy planets like our own Jupiter can only form in the cold, distant regions of a solar system. It just makes sense, right? To build a gas giant, you need a few key ingredients. First, you need cold temperatures. This allows ice to form, which acts like a cosmic glue, helping tiny dust particles stick together to form a solid core. Second, you need a ton of gas and dust to build upon that core. Finally, you need time millions of years for this slow, gradual process to play out undisturbed. Close to a star, none of these conditions are met. The intense heat vaporizes any ice, and the powerful solar wind blows away most of the lightweight gas. A fledgling gas giant would be stripped apart before it could even get started. So, the rule was simple. You will not find planets like Jupiter close to their stars. It was a fundamental law of planet formation, written in the textbooks and taught in every astronomy class. And for a long time, it held true. But then, as our telescopes grew more powerful, we started seeing things that couldn't be explained. We started finding monsters in the dark. It all started in the 1990s. Astronomers began detecting massive, Jupiter-sized planets in places they had no business being, orbiting their stars at ridiculously close distances. I'm not talking about an orbit like Mercury, which takes 88 days to circle our sun. No, these planets were on another level of extreme. Some of them complete a full orbit in just a few days, others in a matter of hours. There are even a few that whip around their star in less than a single Earth day. Imagine a year that lasts only 18 hours. These worlds are often much larger than our own Jupiter, yet they orbit their stars closer than Mercury orbits our sun. They exist in a fiery cosmic forge, constantly blasted by their parent star's energy. Because of this incredible heat, they were given a fitting name, hot Jupiter. And with their discovery, the rulebook of planetary science wasn't just broken. It was thrown out the window, set on fire, and launched into a black hole. Suddenly, astronomers were faced with a planet that, by all accounts, was completely and utterly impossible. So, let's just break down how hostile the environment around a hot Jupiter really is. We are talking about surface temperatures that can exceed 1,000 degrees Celsius, or over 2,000 degrees Fahrenheit. That's hot enough to melt lead, aluminum, and even some types of rock. They are constantly bombarded with intense radiation from their star, thousands of times stronger than what Earth receives from the sun. On top of that, they are battered by violent stellar wind streams of charged particles that blow off the star's surface at incredible speeds. Under this relentless assault, these planets are literally being boiled away. Astronomers using the Hubble Space Telescope have observed some hot Jupiters with huge, comet-like tails of gas streaming off them, being stripped away and lost to space forever. According to the early theories, two things should be true. First, a gas giant should never have been able to form in such a location in the first place. And second, even if one somehow appeared there, it should have been destroyed in a cosmically short amount of time. Its atmosphere completely evaporated, leaving behind nothing but a barren, rocky core. Yet, many of the hot Jupiters we've found are ancient, having survived in this cosmic furnace for billions of years. This contradiction was a huge puzzle. It was a clear sign that our understanding of how planetary systems work was fundamentally incomplete. So, if these planets can't form where we find them, and they should be destroyed if they end up there, how do they exist? Scientists went back to the drawing board and came up with a few fascinating, if not yet fully proven, explanations. The leading theory is called planetary migration. The idea is that these hot Jupiters weren't born in the fire. They were born in the ice. They formed in the cold, outer regions of their solar systems, exactly where our theories predict they should. But then, something happened. Something gave them a push. Over millions of years, they began a long, slow journey inward, spiraling closer and closer to their star. What could cause this? One possibility is gravitational interaction with the disk of gas and dust from which the planets formed. The planet creates waves in this disk, and the disk, in turn, pulls on the planet, causing it to lose energy and drift inward. Another idea is that the gravity from other giant planets in the system could have played a game of cosmic pinball, flinging the hot Jupiter into a new, closer orbit. A more chaotic theory suggests that early solar systems are violent places where planets are frequently scattered, like billiard balls after close encounters, and some just happen to get thrown into these tight orbits. While migration seems like the most plausible answer, none of these explanations perfectly solve the mystery. The universe, it seems, is still holding some of its cards close. But why should we care about these bizarre, impossible worlds? What do they really teach us? Well, for starters, hot Jupiters completely changed our perspective on our own place in the cosmos. They taught us that our solar system, we teats niat, orderly layout of small rocky planets, close in, and big gas giants, far out, might not be the standard. In fact, it might be the exception. They showed us that planetary systems can be chaotic, dynamic, and far more diverse than we ever imagined. The universe doesn't seem to favor tidy designs. It loves variety and chaos. Beyond that, these strange planets are incredible natural laboratories. Because they are so close to their stars, and so large, they are much easier for us to study than planets farther out. When a hot Jupiter passes in front of its star, we can analyze the starlight that filters through its atmosphere. This allows us to figure out what their atmospheres are made of, what their weather is like, and how they respond to the extreme radiation. In a very real way, these impossible planets have become our best teachers, helping us test and refine our models of how planets form, evolve, and survive against all odds. In the end, the story of the hot Jupiter is a perfect example of how science works. We build a model of the universe based on what we can see. We create rules and theories that seem to explain everything perfectly. And then, the universe throws a curve. It shows us something that simply shouldn't exist, forcing us to admit we don't have all the answers. It creates worlds that defy all expectations, and for reasons we don't yet understand, it keeps them alive anyway. Every time that happens, every time we find an impossible planet, our understanding of reality gets a little bit bigger, a little more complete. It's a humbling and thrilling reminder that we still have so much to learn. The universe keeps breaking its own rules. Thank you so much for watching. If you enjoyed this journey to the edge of science, don't forget to like, subscribe, and hit that notification bell so you don't miss our next cosmic adventure. See you next time.